So this is our electron microscope, and they're basically very similar to the normal microscopes you see all around us. But the difference is, with normal microscopes, they have the limit of magnification based on the light. So at one point, light can't resolve a lot of things anymore we want to see, and what we do is, we don't use a light bulb to illuminate our samples in this one, but we use a beam of electrons. And what this basically does, it has a small filament on top, which gets excited with a lot of voltage, and this shoots out a beam of electrons which gets focused in the machine, and then it hits the sample. And what then happens is the high energized electrons that hit the sample more or less hit the atoms that are in the specimen that's in there and shoot out a few more electrons, and these electrons we detect. And this is just the same thing that happens when light bounces off other objects. And we detect this, and then we can see more or less the specimen. And since the electrons are really small, they hit very specific targets on the sample, and with this we can magnify very high, and this is something that light doesn't manage. The really important thing with the electron microscope is it needs to be in a vacuum most of the times. There are newer machines where you don't need a really high vacuum, but basically that shouldn't be any air in between, since the electrons tend to bounce off every atom they hit. So if there's air in between, you have atoms flying around, and when you hit that, you get interference. So we need to have a vacuum inside. The other thing with the electrons is everything you put into this needs to be more or less slightly conductive. So all the electrons you hit kind of tend to charge up the specimen, and when that happens, you need a way for the electrons to flow away. So this happens when you coat it with metal, and the metal we use for coating our specimens with is basically gold, and this happens down here. And the sputter-coater, if you put the sample in a sputter-coater, it again creates a very fine layer of gold on top of the specimen, and this happens with something called a plasma. So all the sputter-coater does, it pumps the vacuum. Again, we always work with vacuum with the SEMs, and you do it like this. You have full of gold on top, and you hit it with a lot of voltage again, so more or less just a current. And what happens is the gold get excited and little atoms pop off, and then you get a more or less gas of gold which deposits very finely on top of the specimen, and with this you get a very, very thin coating. So this is just a few atom layers thick, and so the specimen gets conductive, but we don't obscure any of the features we want to magnify in the microscope. And we have to do this pretty much for everything that's not made out of metal. If you put a needle in the SEM, you can just look at it, because the needle is conductive like any kind of wire. But if you want to look at maybe any kind of plug we found in our samples, we have to coat it first so we get a better picture, more or less. With this you get very crisp and nice images in the SEM.